For the past few months, I've been collecting as many of the chemical elements as I can. And in this series, I'll be showing you my collection and explaining the science behind these building blocks of the universe. Next up is lithium, here on the second row of the periodic table. Lithium, element number 3, is the lightest metal, just over half as dense as water. In its pure form, lithium is a light, silvery metal. In order to store it safely, I have this sample here in kerosene. It's so light that it easily floats to the top. Let's take a piece out to get a closer look. Lithium is a pretty soft metal and is fairly easy to cut with a knife. While the metal itself is shiny, it quickly tarnishes to a blackish gray in the air. Unlike a lot of other metals that react with the oxygen in the air, lithium actually reacts with the nitrogen itself, forming lithium nitride. We all know lithium from lithium ion and other types of batteries, as they play a huge role in the modern electronics industry. From cell phones to electric cars. Lithium batteries are some of the most energy-dense ways to store electricity. And that's due to lithium's atomic properties. Lithium is an alkali metal, like sodium and potassium. Alkali metals have only one electron in their outermost shell. Electrons in the outer shell of an atom are called valence electrons. And these are the electrons that help atoms form bonds with each other. Alkali metals and other elements on the left-hand side of the periodic table tend to have lower electronegativity, meaning that they easily give up their electron, especially compared to other elements with high electronegativity, like oxygen and... Gotcha. We're not talking about you yet, Fluorine. Well, anyway, lithium wants to have a complete shell like helium, so it easily gives up its electron. We can see this in action if we put a piece of lithium metal into water.
Alright, here goes.
It's really tumbling in there.
Yeah. Go.
The lithium atoms in the metal give their electrons to the water molecules, releasing hydrogen gas and creating lithium hydroxide.
And it's gone.
Dump the rest in and see what happens.
No!
Lithium is so reactive that it can't be found in its pure metallic form in nature. Instead, we usually find it in minerals, such as spodumene, lepidolite, and petalite. Spodumene is an aluminum silicate mineral, usually found in granite rocks. And in certain deposits, it can actually grow into huge crystals. Spodumene comes in a few different varieties. such as hiddenite, which is colored light green by small amounts of chromium, and kunzite, which is light pink thanks to manganese. Spodumene is only about 3.73% lithium by weight, but it's still one of the best lithium ores. Other lithium-containing minerals include lepidolite, which is a purple-colored lithium aluminum mica, and petalite, a clear or pinkish lithium aluminum silicate mineral. Lithium can also be found in sea salt and in rock salt deposits, like in the so-called Lithium Triangle in South America. Lithium makes up less than 20 parts per million in the portion of the Earth's crust that's accessible to humans, making it a little over 3 times more rare than copper. Because of its economic importance, lithium is a valuable resource that is mined in many countries across the world, the majority coming from Australia, China, and Chile, along with Argentina, Brazil, and the US. Of course, the vast majority of lithium is used in batteries, with the growth of electric cars and portable electronics. But lithium also has usage in other industries as well. Lithium is used in ceramics as an ingredient in some glazes, or as a flux to reduce thermal expansion. Lithium can be used in welding or in specialized metal alloys. Lithium grease is a water and temperature-resistant lubricating grease that's used in gear lubrication and other industrial applications. Lithium hydroxide absorbs carbon dioxide and is used as an air scrubber in submarines and spaceships. And lithium carbonate is sometimes used to help treat bipolar and other mood disorders, which is most likely what those songs by Nirvana and Evanescence are about. Unfortunately, lithium mining is very energy intensive and requires the usage of a lot of water and acids. This can cause environmental damage, ruining ecosystems and even threatening farms and water supplies of local people. Not to mention the political issues that occur when it comes to exporting, regulation, land rights, and more.
Extracting lithium from brines is a fairly straightforward but lengthy process. First, mineral-rich brine is pumped to the surface. As the brine moves through all the ponds, a variety of other salts precipitate out, leaving behind increasingly large concentrations of lithium. Chile is in the midst of a decade-plus megadrought, and many locals believe that brine mining in the Atacama Desert is exacerbating the problem.
Desde parte de la minería se ha intervenido en todos los ecosistemas, ¿no?
Nosotros vivimos desde tiempo con nuestra hacienda, nuestra cultura, todo.
Estamos preocupados por el tema del agua, más que todo porque somos productores y vivimos de nuestras propias cosechas, nuestro propio sembrado y nuestro propio ganado que criamos llama y oveja.
All in all, lithium is an incredibly important element that powers our electronics, lubricates our machines, and even helps stabilize our moods. It's remarkable just how versatile and vital lithium is to our daily lives.
¡Ah!